Hi everyone. In today's lesson, we're going to talk about the limit definition of the derivative, but this time we're going to use common denominators. So we've seen this limit definition of the derivative for a couple days now. So for this example, we're going to use this same definition, but now to find the derivative of this fraction. So first things first, we're going to write the formula. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now remember, your f of x is your original function. So if you need to write that down, write that down. And your f of x plus h is when you substitute x plus h for all x in the original. So let's do that. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So our f of x plus h, if I want to do that on the side, I can. So f of x plus h means everywhere I see an x, I'm going to put an x plus h. So x plus h here, and then x plus h there, then don't forget the plus 1. So I put the x plus h here, and the x plus h here, and then I added 1. So if I put that in my formula, I have x plus h over x plus h plus 1. And now I have minus f of x, which is my original. So x over x plus 1. So we know that in order to simplify something with fractions, we're going to need to make a common denominator. The best way to do that is to flip-flop the denominators. So this x plus 1 needs all of this, and this denominator needs all of this. So we're going to multiply this side by x plus h plus 1. And we're going to multiply this left side by x plus 1. So let's rewrite what we have so far. We have our derivative, f prime of x, is equal to the limit as h approaches 0 of, I'm just going to make this a little bit bigger. And now we have this times this all over this. So I can write x plus h plus 1 times x plus 1 minus, same denominator again, x plus h plus 1 times x plus 1. So I'm going to start with this times this. That's going to be a little bit easier. But now I see that there's a minus sign. We're subtracting. So what's going to be easier is if we make this plus a negative. So make this plus, and then now distribute this negative x. So it's going to be negative x squared minus xh, and then minus x. All I did was distribute this negative. So now this part, you're going to need to double distribute. So I think I'm going to do that on the side, and then I'm going to place it in. So what we need to multiply is x plus h times x plus 1. So let's double distribute. X times x is x squared. X times 1 is 1x. X times h is xh. And h times 1 is h. Now, unfortunately, it looks like there's no common denominator, so I'm just going to go ahead and put this as my numerator. So we've got x squared plus x plus xh plus h. And now we can add these fractions because they have the same denominator. So we're going to start by rewriting. So we have our derivative, f prime of x is equal to the limit as h approaches 0 of something all over h. But let's make our denominator the same now. So we have x plus h plus 1 times x plus h. And let's add our tops and see if anything cancels. So x squared plus negative x squared, that looks nice. That looks like that's going to cancel. Then we have x plus negative x, that cancels. And we have a positive xh with a negative xh. So that's perfect as well. So just like all the other days that we've done with this limit definition, this whole side should cancel out. If it doesn't, then you're doing something wrong. So really, all we're left with is this h piece. So we're going to say h over the common denominator all over h. Now we should know that we have to use keep, change, flip options, right? When we have two fractions. So we're going to keep, so first let's do this on the side maybe. Keep the h over x plus h plus 1 plus times x plus 1. We're going to keep the top, right? We keep this piece. We change the division to a multiplication, and we flip this last piece. Well, this piece we can't flip unless we make it h over 1. So once we flip that, it's 1 over h. Now look what's going to happen nicely. This top h with this bottom h cancels. So now we're left with f prime of x is equal, well, first actually let's rewrite this here. And we now have f prime of x is equal to the limit as h approaches 0 of 1 over x plus h plus 1 times x plus 1. So now that we've simplified and got rid of these h's, we absolutely can plug in direct substitution now. So I'm going to write that, direct sub. And when we do our direct substitution, the limit will now go away because we're plugging in h is 0. So we've got, I'm going to use this marker here, f prime of x is equal to 1 over x plus 0 plus 1 times x plus 1, right? All I did was substitute 0 for h. So this parenthesis is really x plus 1. So we have f prime of x, which is equal to 1 over x plus 1 times x plus 1. And if you want to get fancy, you can write it as f prime of x is equal to 1 over x plus 1 squared. And that is my derivative. And this will give us the slope of the tangent line at any given x value. So that leads me to part B. Part B says, what is the slope of the tangent line at x equals 5? So all we're going to have to do is take our derivative and plug in x equals 5. So f prime of 5 is equal to 1 over 5 plus 1 squared. 5 plus 1 is 6. 6 squared is 36. So if we want to just simplify this completely, f prime of 5 equaling 1 over 36, what that means is the slope of the tangent line at x equals 5 is 1 over 36, or in other words, the slope. So the slope of the tangent line at x equals 5 is 1 over 36. Now, I know common denominators is probably not the easiest thing, so we will definitely review this more in class tomorrow. If you have any questions, now is a good time to jot them down. Otherwise, I'll see you in class tomorrow. Have a good night.